Hey everyone! Today we're going to talk about sisakulint, a powerful security tool for GitHub Actions workflows.
That's right. If you're using GitHub Actions for CI/CD, this tool is something you really need to know about.
So here's the thing. GitHub Actions has become the standard for CI/CD in open source. But the security features? They're all optional.
That means developers can accidentally expose their pipelines to code injection, supply chain attacks, and credential theft without even knowing it.
Think of it like ESLint, but for your CI/CD security. You run it against your workflow YAML files, and it catches vulnerabilities before they hit production.
It covers all 10 OWASP CI/CD security risk categories. And since it's fully open source with no commercial backing, you can trust there's no vendor lock-in.
It's fast too. Millisecond execution, so it fits naturally into any pipeline without slowing things down.
When sisakulint debuted at Black Hat Asia 2025, it was a basic linter. Look at how much it's grown since then.
5 times the rules, a full autofix system, and a Taint propagation engine that didn't exist before. We'll dive into each of these later.
Every rule now has a CVSS severity score, so you can prioritize what to fix first in large codebases.
Getting started is super easy. On macOS, just use Homebrew with brew tap and brew install.
For Linux users, you can download the binaries directly from the GitHub release page.
Using sisakulint is straightforward. Just run the command in your repository and it will scan all your workflow files.
You can preview fixes with the dry run flag, or apply them automatically with fix on.
And for CI/CD integration, it supports SARIF output format, which works with tools like reviewdog.
Let's dive into some of the key detection capabilities. First up, code injection detection, rated at CVSS 9.8.
Here's a dangerous pattern. When you use pull_request_target trigger and directly interpolate user input like the PR title into a shell command, an attacker can inject arbitrary code.
Imagine someone creates a pull request with a title containing shell commands. That code runs with full access to your repository secrets.
The attacker could steal all your environment variables, tokens, and credentials in a single PR.
The fix is simple. Use environment variables to pass untrusted data instead of direct interpolation.
Sisakulint detects this automatically and can even autofix it for you.
This is the biggest technical leap. Most scanners only look at one step at a time. If the dangerous input isn't used directly, they miss it.
But real attacks chain multiple steps together. An attacker's input goes into a step output, then into an environment variable, then finally reaches a shell command 3 steps later.
Sisakulint's Taint engine traces that entire chain, even across job boundaries and reusable workflow inputs. That's how it catches what others can't.
This is a unique feature that no other GitHub Actions scanner has. Impostor commit detection.
The attack exploits how GitHub's fork network works. A commit created in a fork can be referenced through the parent repository's URL.
So an attacker can create a malicious commit in their fork and convince you to pin your workflow to that specific SHA. It looks legitimate, but it's not.
Sisakulint uses a 3-stage verification process to detect these impostor commits, going from fast checks to deeper API analysis.
Another critical detection is the TOT2 vulnerability in workflow approvals.
This is a race condition where an attacker can modify their pull request code after it's been approved but before the workflow actually runs.
And this detection capability actually led to the discovery of a real vulnerability, GHSL 2025-038.
Sisakulint also checks if you're using any GitHub Actions that have known security vulnerabilities.
Remember the TJ Actions/changed files supply chain attack? That affected thousands of repositories. Sisakulint would have caught that.
Under the hood, sisakulint uses a proper shell AST parser instead of simple regex matching.
This means it can detect argument injection, analyze dangerous shell constructs, and even trace when secrets reach network commands through variable substitution.
It's a much more thorough and accurate approach than pattern matching.
Beyond what we've covered, there are dozens more rules organized into these 7 categories. For example, the cache poisoning rule detects when an attacker can inject malicious content into your build cache.
The credentials rules check for hard-coded passwords in container and service definitions. If you're putting a literal password string instead of using a secrets reference, sisakulint will flag it immediately. Every rule is mapped to the OWASP framework, so you can see exactly which risk categories your workflows are exposed to.
This makes compliance reporting straightforward. Your security team can see at a glance where the gaps are.
These numbers come from testing against real, publicly disclosed vulnerabilities, not synthetic benchmarks.
100% on GHSL advisories means sisakulint caught every single vulnerability that GitHub's own security lab reported. That's a strong validation.
And these affect serious projects. PX4 controls actual drones. The VA's API serves veterans. These are not toy repositories.
There's also a large-scale triage dataset that shows how sisakulint performs in the wild. Over 220 scan reports from trending and popular GitHub repositories were analyzed.
About 60% of findings were confirmed true positives. That's a strong signal-to-noise ratio for a security scanner running at scale.
What's really interesting is the self-healing loop. When false positives were found, they were fed back into the rules. 27 corrections improved detection accuracy over 9 weeks.
During this triage, sisakulint found real critical vulnerabilities in public repos. API keys exposed to external pull request code, code injection in homebrew configs.
This isn't just a benchmark. It's continuous, real-world scanning that proves the tool works at scale and keeps getting better. Let's be clear, ActionLint and Zismer are good tools. ActionLint is the gold standard for syntax validation, and Zismer catches common security patterns.
But here's the big one. Even GitHub's own CodeQL falls short for action security. CodeQL treats workflow files as generic YAML. It doesn't understand trigger types, permission scopes, or cross-step taint propagation.
Sisakulint was built from the ground up for actions semantics. It knows that pull_request_target is more dangerous than pull_request. It tracks taint across steps and jobs. That's why it outperforms CodeQL in both detection coverage and speed for workflow-specific vulnerabilities.
And CodeQL takes minutes to run. Sisakulint finishes in milliseconds. For a CI gate that runs on every push, that difference matters.
No Git clone needed. Just point sisakulint at any public repo and it fetches and scans the workflows directly.
This is huge for security teams. You can audit your entire GitHub organization in one pass, scanning repos in parallel.
And if you want continuous monitoring, deploy it as an AWS Lambda function. Serverless, scalable, always watching.
With AI agents everywhere, you might wonder if a dedicated linter is still relevant. Let's compare.
Imagine feeding 52 specialized rules into an LLM prompt. The context window explodes, and the model starts hallucinating edge cases. You get different results every run.
Sisakulint gives you the same answer every time, in milliseconds, at zero cost. That's what you need for a CI gate that runs on every push.
AI is great for exploration and code review. But for enforcing security policy at scale, you want deterministic tooling underneath. Finding vulnerabilities is great, but fixing them is even better. The autofix system handles 38 rule categories automatically.
Run dry run first to preview what would change. When you're satisfied, run fix on and sisakulint rewrites your workflow files in place.
It handles the tedious stuff, looking up commit hashes for pinning, wrapping expressions safely, adding least privilege permissions. All the things developers skip because they're annoying.
This YAML snippet is all you need. Sisakulint outputs SARIF, and GitHub Code Scanning picks it up natively.
You can also pair it with reviewdog to get inline PR comments. Either way, security findings show up right where developers already work.
Sisakulint was originally created during SEC Hack 365, a cybersecurity research program operated by NICT, the Japanese government's research institute.
It's been presented at major security conferences including Black Hat Asia. And the tool has directly contributed to 20 GHSL vulnerability reports affecting real-world projects.
It's a community-driven, open-source project with no commercial interests.
That's Sisakulint. If your organization uses GitHub Actions, give it a try. One command and you'll know exactly where your workflows are vulnerable.
The documentation site has detailed explanations for every rule, plus examples of real-world vulnerabilities it catches.
Check out the links on screen, start the repo, and start securing your pipelines today.
Thanks for watching, and stay secure out there.